You're looking at a live view of Space Launch System's 5-segment solid rocket booster at Test Stand 97 here at Orbital ATK in Promontory, Utah. This is the second full-scale qualification motor test for the Space Launch System booster. SLS is NASA's powerful new rocket that will have the ability to take humans to deep space destinations like Mars. Today's test is scheduled for 9:05 a.m. Mountain Time, 11:05 a.m. Eastern. Good morning and welcome. We're glad you could join us for NASA TV's coverage of today's test. I'm Kim Henry, and I'm just outside of the Engineering Support Center, where engineers and technicians are eagerly awaiting today's 2-minute test. This morning's test was originally scheduled for 8:05 a.m. Mountain Time, but we did have a delay because of some ground computer systems. Our engineers have worked through that, and we're back on track for a 9:05 a.m. Mountain Time test. Today's test is especially significant because this is the last full-scale motor test before the boosters are integrated with the rocket and the Orion spacecraft for our launch in 2018. We're going to have full coverage of today's test, including the countdown, and interviews with our engineers and team members across the country that are building this rocket. You can follow us today on Twitter at NASA_SLS and at NASA, or use the hashtag SLSFiredUp. Right now, we're going to go over to NASA's Bill Hupsher, who's in one of the test viewing areas. Bill, we were here a little over a year ago for our first qualification test. Tell us how it's going out there today.
So far, so good, except for that slight delay, of course. When we were out here in March of 2015, most of the people who were here were actually hiding under the tents we have to try to stay warm. Today, they're staying under there to try to stay in the shade right before they go ahead and light that booster that's just a little over a mile away from where we are. Once again, you mentioned, of course, we're looking forward to working toward Exploration Mission 1, where we'll be integrating all the propulsion elements as well as the Orion capsule on top of the entire stack there. That'll happen in 2018. And to learn more about EM1, we're joined by Mike Seraphin. He is the flight's mission manager at headquarters in NASA. And first, Mike, if you would, walk us through a little bit about what's going to happen during EM1.
Yeah, good morning. So Exploration Mission 1 is the first in a series of flight tests in the Proving Ground. We're going to fly out in the vicinity of the moon, some 250,000 miles away from Earth, and we're going to launch on Exploration Mission 1 the Space Launch System's maiden flight and Orion on the nose of it, and we're going to fly it and test it out in that new environment of space in the Proving Grounds, where we're outside the Earth's magnetic field, and we see the environment of deep space radiation, and we are flying past the GPS navigation constellation and past our communication satellites in geosynchronous orbit. And we're trying to understand how the system performs in that environment, and we'll get all that valuable data back before we put our astronauts on the very next mission, Exploration Mission 2.
Now, regarding Exploration Mission 1, though, as the mission manager, tell us a little bit about your responsibilities.
Right, so as the mission manager, I'll chair the mission management team and oversee the operations for the launch, flight, and recovery phases. And during the terminal count day, I'll give the go to proceed to our launch director, Charlie Blackwell-Thompson, and the launch operations team in the firing room. And once we've assessed the health and status of the vehicle, the launch ops team will give the go to proceed and actually conduct the launch operation. And then throughout the mission, we'll periodically review the status and make sure that we're on track to accomplish the goals and objectives and to get all that valuable flight test data back. And then at the end, oversee the recovery operations as well, conducted by the ground operations team on a Navy ship that'll sail out into the Pacific and recover the treasure trove of data that'll be on our crew module at that time, and help us inform Exploration Mission 2 and how the vehicle performed in that environment.
Now, of course, this is a major operation involving a lot of different people, a lot of different groups. Can you walk us through the individual elements of SLS?
Yeah, so the Space Launch System and the Orion will be stacked at the Kennedy Space Center. At the very top of the stack, we'll have the launch abort system that is an important safety feature that we hope to not use, but it'll be there for crewed flights. And below that is the crew module, where our astronauts, initially up to 4 crew members, will ride into the Proving Grounds. Sitting below that is the service module that will provide the in-space propulsion as we enter the vicinity of the moon and then exit and head back towards Earth. It's also the power system that powers the Orion spacecraft when it's in the deep space environment via solar arrays. And then below that is the cryopropulsion stage, that serves as our kick stage to push us out of low Earth orbit on our way to the moon. And then below that, of course, is the Space Launch System core stage that contains the liquid hydrogen, liquid oxygen, and fuels the 4 liquid main engines. And then the 2 solid rocket boosters that provide the majority of the thrust to climb to orbit. And the solid boosters are going to be on demonstration here today.
That's a lot of different elements that are all brought together by many different people across the entire country. What's it like to manage such a large group of people in such a large program like this?
Well, you certainly don't do it alone. I'm only one person, and you have an amazing program management team at our NASA design centers and research centers, and then the industry team all across the country. We have suppliers and vendors in 49 of the 50 states. And we've got over 40 different test facilities checking out the various elements and components on board the Space Launch System, the Orion capsule, as well as our ground system. We've got all of the ground support equipment, the umbilicals that we're testing out at the Kennedy Space Center, the spacecraft that we're testing in the thermal vacuum chamber that's coming up in the 2017 timeframe, vibroacoustic testing on the spacecraft, powered testing, and then the core stage. We're going to do a fill and drain, fill it with cryogenic fuel and oxidizer, and then do a hot fire test of it. So we're testing all the components, and this is a test of the booster element. And when you put all those tests together, you've tested all the individual components of the system. And then when we get to the Kennedy Space Center, we integrate it, check it out again, make sure it's ready to go fly. And then we perform a dedicated flight test called Exploration Mission 1. And then that will inform the performance of the vehicle and the design before we put crew on it on the very next mission.
It certainly is an exciting time to be here. So back to today's test. What will we learn from this test that's going to inform EM1?
Well, we're going to see the flight configuration of the booster. The only difference here is it's not pointed skyward, and it's going to be pushing against the mountain for the full duration. It's fully loaded with propellant, and we expect to see it perform like we would on flight day. The only difference is we're going to be able to actually monitor it and see it here on the ground with high-speed video and data, and have a lot more insight to the actual performance. When we get in flight, we actually have to manage bandwidth of the telemetry system that's available, and we won't have quite as much insight, but we'll still have plenty. And this is a great test to confirm our design and that we're on a good path to fly this design of this booster on Exploration Mission 1.
Thanks very much, the mission manager for EM1, Mike Serafin, joining us from NASA headquarters. Let's take a look now at some of the hardware that we've been working on, already under development, as we make our forays into deep space.
And as you can see, a lot of work well underway across our NASA centers and our prime contractors on NASA's Space Launch System, our Orion spacecraft, and the ground systems at Kennedy Space Center. You know, one more piece of that progress is today's 2-minute test here in Orbital ATK in Promontory, Utah. It represents another major milestone on our journey to Mars. And we're just under 20 minutes from today's 9:05 a.m. Mountain Time test. This is actually the second qualification test of the SLS 5-second rocket motor booster. And I understand standing with Bill now as someone who's no stranger to the booster program and this test series.
Not at all. He's been a part of NASA for almost 30 years. Bruce Tiller is the SLS booster manager based out of the Marshall Space Flight Center in Huntsville, Alabama. Now, Bruce, you've been with the space program, as we said, for a little 25 to 30 years since the shuttle era. Yeah. You've seen a few of these ground tests, these solid rocket motor tests. And we'll talk about what everybody's can expect to see here in just a few minutes. But first, now, we all, of course, experienced that we were on a slight delay for about an hour. Can you tell us a little bit about what the problem was, what they had discovered, what the test conductors had discovered?
Sure, they were having trouble with something called a sequencer, and this is for again our ground control sequencer. So what that is a computer program that controls what step happens next during the test. So turn on this system, turn off that system, get the correct sequence. So you have to have that automatic system working to proceed with the test. Now again, that's a ground system. This is not we're not testing that system today other than we need it to test our motor. So the flight systems are a different deal. But yes, that's what happened, and they rechecked it, they reloaded a different one, they checked it out well enough to proceed, and so we're back on track again this morning.
And this will ensure that we gather all the data that we need.
Absolutely, that's the key part. It's a qualification test, so we need that data.
Excellent. So tell me, Bruce, what will our viewers at home see today here in just a little over 20 minutes or so?
Well, so the first thing you'll see is a lot of fire and smoke. This motor puts out 5.5 tons of propellant every second. So that's a lot of, including the dust and rocks it's going to gather as it blows into the hillside. That's a lot of fire and smoke. It's an impressive scene, burns for 2 minutes. If you're watching on TV, you probably will see some close-up shots and you'll see the nozzle move a little bit. We also test the thrust vector control system during that, during the test. So a lot of fire and smoke, some motion of the nozzle, and that's about what you'll see. But the big thing is what you don't see, and that's all the data we're going to gather and that the engineers are going to review carefully in order to confirm and prove that our motor's ready for flight.
Now, Bruce, you'll hear a lot of people use the term solid rocket booster and solid rocket motor interchangeably, but they don't exactly mean the same thing. Can you tell us the difference? Sure,
good question. So this is the motor. We're testing today the motor, and it is probably the largest piece of our booster, but it is just one part of the booster. The booster contains what we call the forward structures above the motor, and then we have the aft structures below the motor, and they have different functions, but critical ones that you have to have for flight. We've got the attached structures where we attach to the core stage. We've got the interface where you attach to the launch pad, and then you got the avionics, the control avionics. You've got the flight safety system. So there's lots of other things that we call the booster.
So you've been here for development motor tests as well as the qualification motor tests last year. What did we learn during those tests that we were able to integrate for this one?
Well, we learned a lot, and we hope we don't learn much today, right? Today's supposed to be a confirmation of all of that, and so today we're supposed to prove that our motor behaves as we expected. But during the development tests, we learned a lot of things. You know, the big one is you're looking at the performance, and there it's the thrust and the pressure, the internal motor pressure that we measure. But there's a lot of other things we want to learn. We want to learn about the seals at every, the joints between the cases. You know, how well are we keeping the gases from escaping? We want to learn about the nozzle and how well it can stand the hot gases inside the motor itself. You want to learn about well, there's just lots of things we learned. But hopefully today is just a confirmation of all of that in our second qualification motor test.
Okay, I've got one last question for you. We understand, though, that while we're here, again, qualifying this particular motor, that the boosters that we're going to use for EM1 are already in production.
We are. We're making a lot of progress. We've already cast 3 of those motors segments, 3 of those segments, and the rest, most of the rest of the hardware is in production at some phase already. So we're making a lot of progress. We're refurbing some of the major structures we talked about down at the Cape. The avionics is starting into qualification. We're going to qualify those in box level and then go to the system level. We're going to, we just got a lot of work going on. But this is a big major milestone for us today to get this cold motor test off to qualify the performance at 40 degrees.
Excellent. Bruce Tiller, thanks very much, the SLS Deputy Manager for the boosters. Now, let's take a look behind the scenes here at Orbital ATK at the motor test.
Great, thank you.
For the people involved in the test, it starts pretty darn early. In fact, it starts months beforehand with the arrival of the first segment into the bay. But the day of test at T-6, we'll make a go, no-go decision on whether we're going to test for that day.
We work with a great group of professionals. Everything from our engineering staff, program managers, our technicians, everybody works great together to orchestrate this thing. And on static test day, when people show up down to the road to watch this test, it gives you a great sense of appreciation and gratitude and a sense of pride.
There's a coolness factor to this job. Being able to see every 6 months or a year the work you've done, actually to see that event that puts the exclamation point on everything you've worked on. Working with astronauts, working with the government, it's very fulfilling.
And took a job at Orbital ATK, and so I got to go down to the Cape for a launch. And at that time, we were nearing the end of the fly out of shuttle. And I could see the two birds, the one sitting on the one pad and the other one, the recovery flight, just in case. And I thought to myself, I would do this job for free. I'm also the mother of a 4-year-old. And there is only really two things that get kids excited about science, and that's dinosaurs and space. And I'm not going to see another dinosaur, but I better keep seeing things going to space.
And that was Janica Cheney, featured there at the end of the clip. She is the Director of Test and Research Operations here at Orbital ATK. Essentially, she's responsible for all the engineers and technicians here today to make this test possible. There are 2 holds planned for today's test at T-minus 15 minutes and T-minus 9 minutes. These holds ensure the systems are synchronized ahead of today's test. And so far, everything is a go for today's on-time test at 9:05 a.m. Mountain Time. Originally, it was scheduled for 8:05 a.m. Eastern. We did delay for an hour because of some ground computer systems, but we're back up and a go. And now we have the opportunity to go out to NASA's Kirk Pierce, who is over to another one of our viewing sites. Kirk, can you tell us a little bit about the atmosphere down there?
Thank you, Kim. We are down here in the viewing area that Orbital ATK has set up for the public to come out here and see the QM2 booster test this morning. We're about 1.5 miles away from the booster test itself. You can see how close we are right over my shoulder. You can see the crowd right through here. They're waving, hey, everybody. Just to kind of give you an idea, I want you guys to kind of look over here at the cars that are lined up alongside the road. Hey, they're waving over here. We've got another overflow parking lot about another mile or so down the road. It is an exciting time down here. At one point in time, Kim, we had a line waiting to get in and talk to our subject matter experts that was close to the length of the booster itself. And they were also wanting to talk to this guy right here, someone who's been up close and personal with the boosters. This is former astronaut Don Thomas. And Don, thank you so much for joining us this morning.
Hey, it's great to be here today. I think I'm as excited as everybody, to join 5,000, 10,000 fellow space enthusiasts to watch this is incredible.
Well, Don, to kind of say that you've been up close and personal is just a little bit of an understatement, because not only have you been beside one, but you've flown in between 2 of these, similar to these, 4 different times. Could you tell us what that experience was like, and actually what the audience is going to experience that may be different from what you experienced during your flights?
On the shuttle, once those solid rocket boosters lit, a lot of shaking and vibration, and I could feel the shove in my back, and I knew immediately I'm going somewhere today, as we were taking off. It's a pretty rough ride, but really exciting. And it's only 2 minutes that they burn and then they drop off. We're going to hear a lot of noise. The flame is so intense, even in the bright daylight that we have here today. It'll be incredibly bright. And I think everybody's going to feel the shock waves pounding on their chests. It's really an exciting time.
Well, we're super excited down here, Don. I know there were a lot of people out here really excited to meet you, and I know you want to get back down there and talk to them. So thank you so much for joining us today, and I just enjoy the test.
It's great to be here today. Let's go.
Let's
SLS.
Go. SLS. Thanks, Don. Hey, guys, you could join the conversation by following us on our social media at NASA_SLS, at NASA, or you could join us at our hashtag us at SLSFiredUp. Now, Bill, I understand you've got some people up there in your area that have been following social media for the past few days.
Oh, sure. We've got a lot of the folks who applied through social media to be a part of this behind the scenes. They've been getting an exclusive look, and they're all gathered out here today ready for this test, just about as enthusiastic as the group you have down there. One gentleman, though, who is very excited to see this test go off is Charlie Bound. He's with Orbital ATK, one of the engineers who's been working feverishly on this 5-segment solid rocket motor. And Charlie, actually, you've seen quite a few of these before, haven't you?
I have. We've done more than 50 tests, and I've probably watched half of them.
Now, a lot went into getting ready for today's test. Can you tell me a little bit about what you and your team did to prepare for it?
Well, for the last several years, we've been doing demonstration motors, 3 demonstration motors. We did a qual motor about a year and a half ago, and then this is our final qual test.
So I know that we've looked at all the objectives, and there appears to be a little bit over 80 official objectives for this. But what are a few of the larger ones that we'll be looking to get from this test?
Well, today this is our cold motor test. We always want to know how the motor will operate at both the extremes of low temperature and high temperature. We've cooled the motor over the past several weeks to get down to about a 40-degree average propellant temperature. And we're there, we're ready, and excited to see how it performs at that temperature.
And that's certainly not an easy thing to do when it looks to hit in the upper 90s here today.
Yeah, that's right. Yeah, for several weeks we've had a giant air handler, a big air conditioner running in the building to push that temperature down into the high 30s, low 40s.
So it is essentially moving in a lot of refrigerators and just opening the doors.
Well, sort of. Huge air handlers, and we've piped that air in, running the air about 30 to get the motor down into the high 30s.
Well, why is it important to test at this lower temperature?
So rocket propellant, that's a chemical reaction. If it's warm, the reaction's faster, and so you create more pressure. And when you're cold, you create less, but you burn longer.
We're seeing some of the video now of behind the scenes of them actually testing the temperature inside the building there, and including some of the pipes that were leading in, and that wasn't white paint you were seeing on there, that was actual frost.
That's right, they're all frosted up.
That's right. So we mentioned the cold test, but what are a couple of other things that we might be looking for this particular test?
So this is our final test of the new insulation, an environmentally friendly insulation. That's a wonderful thermal performer, and we've worked the bugs out as far as processing goes.
Fantastic. Well, Charlie, thanks very much for joining us. Charlie Bone with Orbital ATK, just one of the engineers, and you and your great team here. Thanks very much. You've been putting on one heck of a show, and we appreciate your time.
Thank you. Look forward to it.
All right, yeah, we're looking forward to that test, the official lighting here, and looks like they're in about a hold right now, Kim. But again, everyone out here is really excited to go. People are starting to drift out from under the tents and watch the final minutes as they finalize and get ready to light this proverbial candle.
Absolutely, and thanks, Bill. We are in the second planned hold for today's test, just to ensure we're all synchronized and ready. We want to welcome those of you who are just now joining us on NASA's Facebook Live. We are under about 15 minutes for today's test, and the countdown is progressing normally for our 2-minute test slated at 9:05 a.m. Mountain Time. Now, I had the opportunity here to be joined by astronaut Stan Love. He has an important role in our astronaut office related to deep space exploration. Can you tell our viewers a little bit about what your role and your job is with the astronaut office?
Sure. So most of our work in the astronaut office is focused on the International Space Station, where we have crew members right now. But we have a small group in the office that's looking beyond low Earth orbit, the Orion spacecraft, the SLS heavy lift rocket, and destinations to send people off to the moon, asteroids, and eventually onto Mars. And that's my group.
Yeah. So what kind of work are you all doing right now to get ready for a journey to Mars?
Well, mostly we're focused on the Orion spacecraft. Mm-hmm. The cockpit of that vehicle is going to be our environment when we go on beyond low Earth orbit. So that's where most of our attention is focused. But we're also very interested in the development of this SLS heavy lift rocket. That's going to be our ride off the Earth to low Earth orbit, and then it's going to give us the boost we need to break away from the Earth and head on into deep space. So we're paying close attention to both of those vehicles.
So why SLS and Orion for deep space travel?
That's the only thing we got, ma'am. There's no other vehicle out there that can break away from low Earth orbit and go out into deep space. There are plans for a couple of ships. For instance, the Russian Soyuz was originally designed to go to the moon, but it's never been there, and we're getting ready to go into deep space, and there's no other options.
Oh, exciting time, absolutely, for NASA and our program. And this is the final qualification test before we fly in 2018. So we want to thank you so much, Stan, for joining us today.
Sure, you're welcome.
Thank you. In addition to our TV program today, you can also get test updates on Twitter at NASA_SLS and at NASA, or using the hashtag SLSFiredUp. And also you can watch us live on NASA's Facebook Live. You can also visit our NASA Marshall YouTube page for all the videos you've seen today, including a unique 360 view video. You know, earlier Charlie Bound was talking to Bill about chilling the motor. And here, you actually get to be in the hot seat and see the motor just like you're in there. And we are still in a hold right now. It is one of the second holds planned for today. We will be listening to the countdown throughout, and we'll hear test conductor Matt Longacre and test control coordinator Howard Healy. It's interesting, Howard has actually been here for every solid rocket motor test, starting with the shuttle program. I'm also joined by someone who's also no stranger to motor test. It's Alicia Carrillo, who is an orbital ATK engineer. Alicia, I understand you were here for 9 out of the last 10 tests, actually in the bunker where it's go time, right, where they do the work. Can you tell us a little bit about what's taking place right now?
So right now, while we're in a hold, we're really just trying to synchronize everything, make sure that everything's ready for our final progression. And right now, pretty soon we'll be seeing the arming crew evacuate the bay and come in and basically just do their final sweeps.
Okay. And I think we're hearing that they're just ensuring that the temperature is accurate, that we're good to go for that?
Right, so they'll be checking out one of our support systems, and we have a lot of temperatures that are in place, a lot of constraints to this test. And so we'll be watching all of those temperatures very closely.
Yeah, and it is important to test at this temperature. Tell us a little bit why.
So our cold temps PMBT is basically, it's really important to bracket our flight performance requirements. This vehicle has to be able to fly from a propellant temperature of 40 degrees to 90 degrees, and we really want to maximize our launch availability windows. You know, being able to go to deep Mars doesn't come around very often, and we want to be able to take advantage of those planetary alignment opportunities with a vehicle that's robust.
So, the way I understand it is, when you're on the launch pad and you know the temperature of that propellant, you want to know exactly how it's going to perform, so you'll know the trajectory and you'll know everything about how it's going to fly.
Right. The temperature does affect a little bit how the propellant burns. It affects motor performance, and we need to be able to dial that in for vehicle trajectories.
And we're about 7 minutes out from today's test.
So one of the things to watch for as we come a little bit closer is the arming crew coming in.
Okay. Can you tell us a little bit more about what the arming crew is?
So right now we have a fire control system, and it's pretty elaborate. There's a series of safety requirements in place. And one of the last things to come into play in the bunker is an actual key. So you will see them pass down. It's actually a little padlock key. And the operators that are clearing the bay have that key in their possession. Make sure that you cannot fire that motor any earlier than we want to.
So much like you need a key to start your car, you need a key to start this booster.
Absolutely, it requires a key. And we'll see them when the arming crew gets in there. We'll actually see them pass the key down. And Howard Healy, the test control coordinator you spoke of, will actually insert the key into the fire control system.
So is that what it says? We are surrendering the fire line key. Is that what's happening right now?
That's correct. I haven't seen them pass it down just yet, but when the arming crew gets there and we've made our final sweeps that we are ready to go, we'll see them actually pass the key down. So when they say surrender, you know, it's one of the safety features. The arming crew will keep that key in their possession, and then they'll literally surrender it to the test conductor, which says we're ready to go. So there goes the key, and so now we are closing the fire line. We're basically all hooked up and ready to go.
Okay. And we're about 6 minutes away from today's test.
This is the test conductor. Turn on the water boost pump.
Can you tell us a little bit about the water system that's in place? They are talking about putting the water boost pump on.
Right, so one of the important features for post-test is the deluge system. And so it's basically a really powerful sprinkler system. And so what we want to be able to do is cool the motor down post-test. We want to be able to get the motor cooled down so we can go in and do some inspections. And so there's literally sprinklers underneath the motor. And boost pump just pressurizes those sprinklers to make sure they're going to work.
And while this motor will be a cold motor test, it will be hot inside that motor, nearly 6,000 degrees, enough to boil steel. So it is important to have that water in place.
T-minus 5 minutes. T97 test area is clear for static test. High-speed data operators verify systems.
There's the key.
He is inserting the key now.
All high-speed data systems are streaming. Roger.
And we are coming shortly up on the T-minus 4 minute mark in the countdown, where we will hear the polling from all the various stations. Each station will report go before we proceed for ignition. Among the stations you'll hear make a call are the support systems, various data systems, and avionics. Yeah, so let's not come back on this shot. Hey, Mick.
Don't go back on the.
T-minus 4 minutes. This is the test conductor. Report system status. Central support system is go for static test.
Low-speed data systems are go.
High-speed data systems are go.
Ultrasonic data system is go.
Avionics system is go.
Red light monitor system is go. Bus monitor system is go.
Motor temperatures are go for static test. We are go for QM2 static test.
And with that, all stations are a go for today's ground test of the Space Launch System booster.
T-minus 3 minutes.
And at the viewing areas, all eyes are on the countdown. We are now less than 3 minutes from the firing. Alicia, can you tell us a little bit about what's happening right now, just shortly before this test begins?
Right, so right now, all of our data acquisition systems are basically getting queued up. We'll be gathering 600 gigabytes of data for this test, and everything is initiating. All the data systems are starting up and the cameras.
And that's really important.
T-minus 145 seconds.
Right, we conduct these tests to gather data. Recording. It's important to be able to get all that data.
Yeah.
All high-speed data systems are recording. Roger.
And I believe there are 82 test objectives, over 530 instrumentation units.
That's correct.
T-minus 2 minutes. Low-speed data operators begin recording.
Roger. All low-speed systems are recording.
Roger. Bus monitor operators select stop all followed by start all to begin a new recording file.
Bus monitor is recording a new file.
Roger.
Ultrasonic system is recording.
Roger. T-minus 90 seconds. T-minus 80 seconds.
Test control coordinator, stand by to commit the motor.
Standing by. T-minus 70 seconds.
Commit the motor.
Motor is committed. T-minus 60 seconds.
1 minute to ignition. The test is a go.
T-minus 50 seconds. T-minus 40 seconds. Pad flush is on. Roger. seconds. Minus 25. T minus 20. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
And we have ignition of NASA's Space Launch System's solid rocket motor powering us on our journey to Mars.
CO2.
And the full 2-minute SLS booster test has concluded. Alicia, can you tell us a little bit about what's happening right now? I believe the quench arm should be coming in.
Right, so we'll be swinging the quench boom. You can see it start right now. Basically, that's really important. It's going to, like a big fire extinguisher, right? It's going to go put out the fire on the inside of the motor. One of the major objectives we have is to go take this motor apart. We'll essentially do a very thorough dissection, and we kind of want to freeze time and stop the motor in its configuration that it's at from the burn, such that we can go and see how it did.
And I even understand there is a nozzle plug there, that it's important that you have a camera to watch how it breaks up, and that also that you go and collect those pieces afterwards.
Right, so we'll actually have we had a mirror pre-test, and that mirror will help determine how the nozzle plug broke up. We'll have a crew that goes up after we've determined the area is safe, and they'll go collect the pieces of the nozzle plug and evaluate them for size and the debris that we've generated.
I even understand they go through and they actually number the pieces and sort of graph it out so they specifically understand exactly how it breaks apart.
That's correct. The nozzle plug had a grid drawn on it, very detailed, to be able to orient it and put the puzzle back together.
Mm-hmm. And that nozzle plug will be in the booster when it launches. You need it there to ensure your motor is at the right temperature. And
right, it's basically just an environmental seal. You want to make sure that that you're controlling the moisture in there and kind of keeping the animals out as well.
Yeah, all right. And what else is happening for today's test? I mean, the test is over, but it's far from over for you guys.
Right, so we'll basically be in a stand down for about half an hour. We'll send a crew back in, basically in the reverse order that they evacuated, moving through every step of the way, making sure that it's safe along the way. We'll have our post-fire crew up there doing a quick once-over, and then we'll basically just safe the motor, close it back up, and start a very detailed post-fire inspection.
All right. Thanks so much, Alicia Carrillo here, a NASA Orbital ATK engineer. Experienced it from the Buckner, and this time experiencing it with me outside the Engineering Support Center.
Thank you.
All right, and that certainly was an exciting test. Even here, we're about 3 miles away from the test, and you could actually feel reverberation in here and the doors vibrating a bit, a very powerful booster. But what I really want to know is I want to go out to Kirk, who's in the public viewing area. Kirk, how's it going out there?
Man, I'm going to tell you what, the level of applause that the booster test got for the public down here, it was great. Everybody's just so excited. And I've got two people here with me that drove a long way. They came from Wyoming. They came great distances to be here and be a part of this test today, just like NASA's working to go great distances in our solar system. I want to introduce everybody to Leslie and Dave Uraski. Leslie, Dave, you guys are teachers. Leslie, I got to ask you, how was that?
That was one of the most amazing things I've seen. Ever since I was 12, I thought I would be the first geologist on Mars. And now that I'm a high school teacher, it's my job to get other young ladies have that dream.
That is awesome, Leslie. Now, Dave, you're a retired teacher, and you used to teach, what'd you say, technical subjects?
Technical education.
How was this for you?
I like things like this because it allows you to take the students from the current technology to think outside of the box to what's in the future.
Yeah. So, what are you going to go back and say?
I'm probably going to cry when I tell the kids because seeing this in person makes it real.
Absolutely. Well, guys, thank you so much for coming out here today and be a part of this with us. Just thankful that we had the thousands of people here with us as well. Hey, guys, listen, our work's still kind of going a little bit. We've got a lot of people still trying to get over there and talk to Don and talk to our subject matter experts. But Kim, I understand you've got somebody who with you right now. Oh, Bill, I'm sorry. Bill, I understand you got some people there that really, for them, this job is just getting started to collect the data and everything that they need.
Oh, that's right, Kirk. Yes, Orbital ATK pulled off a fantastic test. I'm joined by Charlie Precourt, Vice President, General Manager of the Propulsion Systems. It's right here at Orbital ATK. Right. And, of course, veteran astronaut. This is fantastic. It was such a great test. The most impressive part to me is always when you see the light flash, you see the smoke, and then 6 seconds later when that shockwave hits you, and everybody in the crowd reacts almost the same way, going, ooh. They weren't almost like they were like, why is it quiet? And now there's the noise.
They weren't expecting that, were they? It's always a surprise. That rumble that you get is awesome. And, you know, watching it for 2 minutes and 6 seconds and then seeing the thrust level dwindle down, you know, you start to feel really good that we made it through exactly what we were looking for. Beautiful test.
And I think that a lot of people don't understand that when we watch them as they launch off the launch pad down at Kennedy, you get that initial shockwave and, of course, the noise, but it's going away from you. Here, it's 2 minutes right here on the ground, just barely over a mile away.
Barely over a mile away, as opposed to 3 miles down there, and with the background of the canyon there reflecting the sound even more so. So, yeah, we get a lot of energy out of it right here.
Okay, so Charlie, tell us a little bit about what the team is up there doing right now. We know they've quenched it, but what's in the immediate future for the engineers at Orbital ATK?
So we're right now we're into the mode of conserve the forensic data. So we've got the test has been completed. We got our way through shutdown. We want to freeze everything in the condition of the systems exactly as they were to the degree of our capability at the moment of shutdown. That way we can go in and we'll be actually disassembling the motor over the next few weeks. Take the nozzle off, take the segments apart, take the dome off, the igniter out of the front, and we'll be starting to dissect the motor to make sure every component is in the right condition as we expected and that it performed the right way. That's all about qualification, right? So we had 530 channels plus of data. All those parameters will be looked at. We have film, we have acoustics data, we have temperature sensors. All of that will be dissected over the coming months to make sure this worked exactly as we wanted it to.
In the meantime, you're already under production with some of the motor segments for EM1.
We are. We have EM1 well underway. I think we're at least 3 of the segments are all the way through propellant casting. All the other segments are being processed for insulation. We clean up the case to make sure it's pristine before we put an insulator in the inside of it. Then we put the propellant in on top of the insulator, and then we do that for all 10 segments of the 2 boosters. But we're well into casting the propellant for the left-hand booster of EM1.
Charlie Precourt with Orbital ATK, thanks very much for taking the time. Always a pleasure to speak with you.
Likewise.
And Kim, we're watching the smoke plume start to dissipate out here at the test area, but let's head back inside with one final check on, I guess, the initial analysis of this test.
Absolutely, and thanks, Bill. I'm sitting here with Alex Priscus, who is the NASA Space Launch System Booster Manager. Alex, how do you feel after that test?
Pretty great day, isn't it, Kim? That's always a blast. It's really a fantastic day. I'm so proud of this team. Mm-hmm.
It is a great day, and it is our final test before we launch.
It
right?
is.
So where are we at with that?
Well, the next boosters, actually, we tested 5 segments today, which make up 1 booster, so we've got to build 10 segments for our first flight, EM1. 3 of those are already built. So 3 of those have propellant in them. We got 7 more to do. We're building structures at KSC, getting ready for EM1, so we're well on our way to EM1. But I'll tell you, I'd like to take a moment and reflect on this morning. You know, this morning was a really super day. And we did have a few issues with some of our ground test equipment. It had nothing to do with the motor or anything we fly, but we had some computer issues and some hardware issues. We started working some little instrumentation issues about 1 in the morning, and then we had an issue with the sequencer. The team did a great job of working through those. They absolutely did. They assessed the problems. They came up with the solution, gave Fred and I a great rundown on the risk and the readiness, and you guys saw the results. It was a fantastic test.
Yes, absolutely. A total team effort here between NASA and Orbital ATK for this solid rocket motor test, the final test before we launch in 2018. And it is a major milestone on our journey to Mars. From the entire NASA team, I want to thank you for joining us for today's live coverage of this test here at Orbital ATK in Promontory, Utah. We'll now conclude today's broadcast. To follow the progress of NASA's Space Launch System, you can follow us on Twitter at NASA_SLS and NASA, or go to our Facebook page at /NASA SLS, or visit our website at www.nasa.gov/SLS. And for all the latest news from NASA, visit us at www.nasa.gov.
Fire. +5. +10. +20. +30. +40. +50. +60. +70. +80.
Central Support Systems Operator, enable the deluge CO2 and quench tool controls.
Controls are enabled.
+90.
Open the accumulator enable valve.
Accumulator is enabled.
+100. +105.
Activate aft deluge.
Activated.
+110.
Activate forward deluge.
Activated.
T plus 120 seconds.
Activate head end CO2.
Activated.
Activate quench tool command forward and aft CO2.
Activated.
T plus 145 seconds. 2, 1, fire.
And we have ignition of NASA's Space Launch System's solid rocket motor powering us on our journey to Mars. The full 2-minute SLS booster test has concluded. Alicia, can you tell us a little bit about what's happening right now? I believe the quench arm should be coming in.
Right, so we'll be swinging the quench boom. You can see it start right now. Basically, that's really important. It's going to, like a big fire extinguisher, right? It's going to go put out the fire on the inside of the motor.
10,